everyone. This is Namit Nayak. I'm based out of Chicago office. I'm working with PS from last 8 years. I will be going to talk today about how we can bring machine learning on device. This has come up from the idea behind to bring up machine learning on device is not new. It's Apple started this in far back in 2010 and 2011. They're coming up with the CoreML, but we are for me, it's like when we are pitching a new thing for our client and we want to do certain things within the device and we want to make our app more smart, more intelligent, then it comes out how can we do such stuff within the device rather than interacting or using a big infrastructure or other stuff which is already available in the market. I know you have already gone through with a lot of other machine learning sessions in our XE Summit 2020, like eSpy. I will be going to give you some other kind of walkthroughs, what we can do with machine learning on the device. I will be going to talk today about machine learning, how we can use CoreML, how it is easy to use CoreML, what trick and tips we should use when we are planning to train our model, and some cool stuff about CoreML. And time permits, I will be going to showcase you some POCs. So let's start.
As technology evolves and the world's population grows, so does the amount of data being generated. Collecting, sorting, and analyzing all of this data can be pretty time-consuming. However, that's starting to change with the emergence of something called machine learning. Machine learning is a type of computer science that allows computer programs to learn and improve all on their own. In the past, computers could only do what we programmed them to do. But with machine learning, they can behave like humans and gain knowledge based on their past experiences.
Yeah, so this is a very quick introduction about machine learning. I hope everyone knows how machine learning works. By giving certain data as an input and tracing out how that works and how the processing did to identify the certain patterns. Now, for machine learning, we need to know there are certain different kinds of learning processes which we need to know when we are trying to train our model. One of them like reinforcement learning, where we will be using reinforcement learning to train our model from experience and over time on the basis of its actions. This will it's try to explore an agent environment to learn how to perform specified tasks by taking actions with good outcomes and avoiding actions with bad outcomes. Another type of learning is supervised learning. This is a specific technique to generate a prediction or classifications. The goal is to take input data and output data and then train an algorithm on how to connect the dots between the two variables. The last or not the least is the unsupervised learning. This type of learning where we just get the input data and the distributed input data, which we are going to connect and see on the basis of learning how we can connect the dots from the input data. We will going to leverage these kind of learning processes to train our model. I would like to tell you about more on CoreML. So CoreML is a framework which was brought up by Apple in 2011, where you can use CoreML to build the mobile applications more smart and more intelligent. And of course, the important thing is you can do this thing within the app. This is the high-level architecture diagram of your app looks like when you integrate a CoreML SDK with your app. You can perform many operations like vision, natural language processing, speech, sound analysis. We will be going to talk through in all of these topics in detail in my session. Why we want to go with the CoreML? What's the benefit of CoreML? Let's see this. First one, yes. When we see that when we want to run a model, we can do it fully on the device. What it means that we don't need to connect to any cloud system or any backend system. You can just put up your app, includes the model, and it can perform the certain task on the basis of your model train and gives you certain outputs. Another important thing is These models are very highly encrypted. Even if your device is jailbroken, someone cannot pull down your personal information which is already put inside this machine learning model. Another important thing is Apple provided the CoreML provided supports for all the different types of machine learning algorithms or machine learning frameworks which is already available in the market. For example, PyTorch, TensorFlow, Keras. So if you think from a developer point of view, sometimes it looks like when someone say, hey, can you develop something in machine learning? We always thought, oh my God, I need to write a lot of Python code. How would I understand the big log algorithms there? Now, by this, it's going to be very easy and a very specified job to do perform certain actions. Now, the important part is you can personalize your model on device. What it means that you don't need to connect to any system outside of your device, and you can train your model within the device with certain actions done by the users. This way you can create certain personalized experience for a customer without sending their personal information outside from the system. Last but not the least, now CoreML supports advanced neural network. What it means, for example, right now, if someone wants to detect a multiple objects in an image, we usually use a third-party tools and send an image via live streaming object to the server, and it's able to give us a response back like identifying all the objects. Now you can perform all these tasks offline within your device. So that's why these are the best. This is why the CoreML fits if you want to develop a machine learning user experience for the devices. Let me give you a quick brief about CreateML app. This is one of the small and a very innovative app developed by the Apple, which comes under the Xcode, where anyone, I will say not only developers, even a non-technical person can train their model, can generate a model with a proper data set. So let's talk about CreateML app. For that, you just need to go to the Xcode developer tool, and in the developer tool, there's an option for CreateML. This is a cool and a very simple IDE for CreateML app. I will be going to give you a quick walkthrough, a quick demo, how we can use a CreateML app to generate a model. And within a 15 to 20 seconds, 15 to 20 minutes, if you have all data sets, you can generate your model and just integrate in the app. That's it. And just few steps, you can use that trained model to make your app more intelligent and smart. So now CreateML, that's the another. CreateML supports a different varieties of classifications. That's right. In the CreateML, you can identify the objects. You can create a model for identifying the objects, image classifications, word tagging, sound classification, text classifications, tabular classifications, and even activity classifications. So is it interesting? Let's see how it works. So here is my CreateML app. I will be going to use one of the existing project of my CreateML app, where I will be going to train our CreateML app with certain data. So when you press on new document, you can choose this image classifications. Just choose this image classifier. I'm going to demo you about image classifier here. So I choose image classifier. I can name it like, I will be demoing you about to identify whether the certain image is of chef or not. Okay. So I say identify chef. Give it license version 1.0. You can create as many as you want. It's a very simple version of app, and trained your model. So important thing here is you need to provide two important data. One is the training data and another is the testing data. So once you provide this data, you can run the iterations to train your model with the training data, and then you can run the testing data on top of it. And once the model is generated, you can validate whether your model is predicting correct or not. Here, you can, by default, Apple have provided 25 maximum iterations, but you can set it up as much as you need. You can make it 30 or 40. Please keep in mind, you should have more for a model. You should have a more training data. As much as you have more training data, you will get more accurate results. So let's go through it. I will select some files. I already set up a training data folder, which have two folders like whichever two folders like this, testing data and training data. And training data, these are the images which I put up as in the specific folders, and the naming convention which I give this make this for this data as a supervised learning data with a classified label. Okay, so I just give an input. I will going to give an input as a training data here. There are all 16 items, and I will also select my testing data like this, and just press training button. So now my training is going to be executed. That's how the training done. Now I will going to execute the testing of the model. Now I trained a model with certain images, and also I trained a model with and also I put up another testing. So if you see here on the output side, I got a model generated which is of like just 17 KB, which I can simply use and simply integrate this model file, and I can just drag and drop somewhere in my desktop, and I can get a model file which I can use and integrate with the app, and use this identifying the chef feature in the app. Let me add you one file here and see how this behaving. Is my model behaving correctly or not? Let's see this. Oh yes, see, you were saying that I just give an image and it's able to showcase that it's a chef. Isn't it cool? So if I don't know anything about machine learning, and if I think machine learning is a very hard thing, this is the way you can simplify the usage of machine learning. Let's go back to our presentation. There are another way to use the generate a model for CoreML. Another way is like CoreML Tools, which is a CoreML tool script where you will run these scripts. There are predefined Python script for CoreML Tools where you can generate a model with any of these following frameworks which provides the machine learning algorithms. So using CoreML Tools, you can convert ML model with any of the following packages for any of the models. For example, neural network, pre-assembles, generalized linear models, or pipelines. Let's see how that works. Is it a big deal, or it's a simple step? It's a very simple step. You should have few things to be set up in your machine. First of all, you should have a Python installed. I believe that's, as all developers, we will have that as engineers. Now you can use either a Jupyter notebook, or you can use an Anaconda IDE for doing that. Now simply import like I'm going to give an example using a TensorFlow. So I just need to import a TensorFlow Keras API. What I will do next, I will use one of their algorithm or a model to detect the images for like image classification, like MobileNet V2 model. I will import that specified model, retrieve their class label in just a few lines of code, and simply using the CoreML tool script, it's a one-line code to generate a model. I will get a model generated, which I can save to my desired location in my machine and simply integrate with my project. So this way, I can use already available models in the market which are already giving us a better output results for certain operations. Let me show you that quickly, how that my scripts look like. So I just run through a Jupyter notebook on my machine. And if you see here, I'm just going to open one of my simple version of a script language, which is just converting a mobile net V2 model, which is of a TensorFlow Keras model, into a ML model. If you look upon here, it's a simple 10 line of code which can generate a model. Once you run through it, it's going to generate a model and save it in my device. It generates the model like this, and you can integrate this model within your app and simply perform certain tasks. So this way you can integrate any different models available in the systems within your app. There are certain specific guidelines mentioned for human interface guideline mentioned when you're creating a mobile app for machine learning. For example, you need to ensure that the behavior of your model is not impacting to the experience, and your experience should also understand what kind of data metrics we will get from the model. There are predefined rules mentioned by the Apple which we should follow when we are considering to integrate machine learning in our app. I will be going to talk one of them in detail. Like for example, critical or complementary. So think about it. When we are using an iPhone, we see a Face ID recognition. Face ID recognition is the best example of machine learning implemented in your device, and that's all within the app. So if you look upon to that, for Face ID recognition, Apple is not sending any information to their server or cloud. It's doing that calibration within the device using the machine learning. So a feature like where we want to develop a Face ID kind of feature, then machine learning becomes a critical. Now where we can see is a complementary. A simple example is of keyboard suggestions. Without keyboard suggestion, I can still write something on the keyboard using the keyboard in a phone. But providing a suggestion is help me out or help users to just quickly complete their sentence. So keyboard suggestion becomes a complementary way to implement a machine learning. So same way, there are different ways like proactive, reactive, or public or private data, dynamic or static, or visible, invisible, certain different kind of roles which we need to ensure when we are implementing machine learning in the app. There is a very important thing comes up when we say a public or private data. If we are using a public private, if we are using a private data of a user within the device, like we are not sending it to any server or on a cloud, we need to ensure that our model is providing the results with more accuracy and more benefits. So let's talk about how can we train our model as an input and output. There are certain specific guidelines. When you are running your model on a device within your app, you can train your model within the device by doing certain inputs, by taking certain inputs. For example, explicit feedback. For a specific workflow, you can ask customer to give you explicit feedback, which can be used to understand customer behavior and nature to give a certain outputs. Similarly, implicit feedbacks where we can identify the customer journey and what they are going to use for how they are using the app and the business use case. We can certainly show a different kind of personalization for that. Another way is like calibration. Best example is Face IDs. Like we are the different calibrations. We want to check a customer identification in Face ID. That also helps a model to train within the device. Now, when we give certain inputs and a model trained to itself, there will be certain different types of outputs come up. For example, there could be the reason that the outputs which are coming up may contain some mistakes. There are multiple options. Confidence and attributions and limitations. So we just need to ensure that when we are going to look upon for the output, We are checking how much is the confidence level of that output. And that's really good that we are getting the multiple options to select and to choose and to ask and to provide to customer to choose between one of them. Now let's talk about a very interesting subject, which is binary confusion matrix. I know person who works on the machine learning, they heard about it, and this is really important to understand why we need a binary confusion matrix. When we work on different models and when we are working on some specific client requirement, we really need to know how we are going to identify the performance of our model. So this is a matrix where you will be see whether your model is actually identifying or actually predicting the case for the actual yes case or it's not. Let me explain you this with this very funny example. A lady which went to a doctor and say it's pregnant, if she is pregnant, then yes, pregnant, it's true. So this becomes a true positive. It's actually a pregnant and it's predicted as yes. Whereas a male went to a doctor and say I'm pregnant. This is error, right? Your model is saying it's pregnant, but it's not. So this is a false positive use case. Similarly, false negative, where lady is went to a doctor and say I'm not pregnant, but she's actually pregnant, and doctor saying you're not pregnant, then it's a prediction says no. That becomes a true negative. Whereas if a male say I'm not pregnant, then it becomes the correct prediction, which says true negative. So we really need to identify our classification models, how they are going to behave when we are training those models. So let's understand more. I just try to use fries available in the market, different images of fries, like around 150 images, and I trained a model with that. Out of that, actual fries identified by model is 50, where there are 5 images which are not actually fries, which are actually fries were identified, which are not actually fries were identified as a fries. Whereas there are actually 10 images, 10 images of images which are actual fries but are not detected as fries. So this way I can see that my model is like, if I provide a different 150 images as a test data to identify the for an image classifier, the model's behavior is a little different. Now let's talk about there are different kind of metrics available to more go deeper and identify the performance of your model. One of them is a recall matrix. Recall is a fraction of relevant information that are retrieved. It's also called as sensitivity, true positive rate, or completeness. That means when you are going to create a binary confusion matrix for your model, you can calculate a recall matrix, which is the data like a sensitivity of your model that will help you to understand how your model behaves. Let me explain this to you with a very good example. Consider a current COVID-19 situation, and now lots of pharmaceutical companies are coming up with their test kits. Do you really think the test kits which they are coming up in the market and where they mentioned that it's going, their percentage rate is like, say they said 90% it's going to give a right result? Are they really running those on a human? No. They run certain tests on the humans to identify the results, but they do the predictions, and using the machine learning, they identify what will be the percentage, what will be the model percent, or what will be the accuracy level of their test kits. So let's see. There are a bunch of people who were identified as COVID-19 patients, but one of them is detected as positive, right? But it's negative. What it means that your model, your test kit, which actually needs to identify that model, it's negative, it's not COVID positive, but it's directly negative. And in that sense, you can understand how the accuracy of the test kit comes into the picture. So doing that, this can be easily identified when they are training their test kits and they're identifying the accuracy level of their test kit. They need to ensure they are using a proper data set to train their model. Now let's talk about one of the other metrics, which is the precision matrix. The precision matrix is also called as a correct positives, where you will going to do a true positive, where you will be going to use it to calculate for the better precision results. So let me tell you about one of the another example, which is to identify a fraud in a credit card. Now, in the fraud detection, let's say I have around more than a 17 thousands of file, like around a file, 1 millions of files with me, data with me, test data with me, in which actual fraud is of 71,000. Whereas there is an actual fraud of 45,000 which is not detected. So if you look upon, if I calculate this, then my precision, then the accuracy level, which says the formula for accuracy, comes out 99%, but the precision is just 61%. What it means that my model, which is giving me the accuracy at a very high level, but its precision rate is very less. And this way, we can identify and judge our model whether our model is trained with the correct data or not. There is another matrix which is really used in the world of machine learning, that's called as F1 score. Why we need to have the F1 scores? So F1 score is simply like we can have like true negative upon true negative plus false positive, or the different formula is 2 into precision dot recall upon precision plus recall. If we have a precision and recall both available, we can calculate an F1 score for a certain models. The important place where we use F1 score is where we have multiple models coming up better accuracy and precision or recall rate, then it's better to calculate their F1 score to identify which one of the model is best. Let me tell you this another example of cancer patients. So another reason where we need to calculate the F1 score, when we want more false negative and false positives as a crucial parameter to compare. So consider this cancer patient use case. Here we have a cancer patient use case where we have identified that certain patients are identified as cancer patients. But if we say we want to really know what exactly number of patients are actually not a cancer patient. So in that scenario, it's better to calculate their F1 score. And this way, we will be able to identify that. These are the certain metrics which really help us to identify which of our classification models or any models which we are using to integrate within the app is going to give us a better result. These are some predefined models available by the Apple in as we can integrate this one of the models within the app and simply use it. But with a certain specific business needs, we can use CreateML app to create our own model. Now let's talk about something for Vision Framework. Vision Framework, this is another framework which is provided by Apple, which use CoreML to do certain tasks, like for example, face landmark detection, text detection, barcode recognition, image registration, or general feature tracking. You can use Vision Framework, which is a very highly supervised framework, to identify certain stuff. These are the different tasks which a Vision Framework performs, like vision saliency. They can identify a spatial object using Vision Framework. We can identify a spatial salient object within a video or an image, and that too locally. One of the important thing here is the trajectory detection, which recently added by the Apple in a Vision Framework. As a cricket lover or a soccer lover, we really want to see the ball's trajectory or a ball's trajectory, how balls goes into like in a cricket or a soccer. This trajectory detection, you can perform and see the ball's trajectory how within the app without connecting to any backend servers. So how that works? So consider this: a goal of a footballer kick a ball, and you have a live streaming video. You can simply identify its trajectory, where the trajectory starts, and detect the trajectory. While doing that, we need to ensure that we are following certain rules when we are writing a code for a vision trajectory detection. For example, we need to ensure that we are filtering out all those confidence scores which are not matching with our criteria. We also need to ensure we are giving a proper camera resolution as per the size of object which we want to recognize. We need to know when we are, what will the size looks like when we are going to detect that object in a video or a live streaming. Also, we really need to filter out any irrelevant directional movement which is provided by the vision trajectory detection. Last not the least, we really need to know that which really direction we need to look upon while detecting the trajectory in the app. There are certain methods which provided by the Apple which we can simply integrate and use it for the vision trajectory detection. The important part of here is we really need to ensure that we are giving details about minimum object size and maximum object size, which will help us to give us a better result. Not only the vision framework, there are certain other stuffs which is really important, like natural language processing, where CoreML supports natural language processing, that too on the device in the offline mode, where you can either detect a language identification, you can do a tokenization, part of speech, lematizations, and certain different tasks. So you just need to give a certain text as an input, and then you can get an analyzed text where you can identify that language detection or tokenization. So this is one of the another feature of CoreML. Now CoreML also supports speech recognition. But it means that using SF speech recognizer, you can provide a different kind of speeches and it can do certain operations on it, and that too offline, and give you the transcribed text. Right now in offline mode, it supports 7 different languages, and you can identify like 7 different languages for a speech recognition. And as an output, you can get as a description, alternative interpretations, confidence level, timing information, like that. In an offline mode, you can perform a very different task, which we really need to use when we really want to recognize something. So another important thing is sound analysis. The CoreML also supports sound analysis. What it means, using the CoreML, we can identify certain different types of sounds, give it as an input to a CoreML sound analysis object, and it can generate the output with a certain confidence level. This way, we will be able to identify a different sound analysis within the mobile app, and that too offline mode. So consider the one of the current example, when you went outside, when you went for your holidays or vacation in a different countries where you don't know their language. There, you try to use your Google Translator app. Now, if you have an internet issue, sometimes you're not able to get the conversion, right? You really need to have an internet issue. You really need to need internet for Google Translate app to get the translations. Now, using such core ML features, we can develop certain apps which really can work offline to perform certain tasks. Now let's talk about machine learning bias. We just see how machine learning works with the different learning algorithm. So before we go into this video, I want to show you one example. Let me going to create our new project in the CreateML. It's again the image classification, where I'm going to identify chef gender, and I just create a version 1.0. Now here I'm going to give a certain training data. So I'll create it here. Now I am going to choose some files. As a training data, and just a second. Okay, just a second. Let me do this quickly again. So project, just adding up a version and adding it to the project. Signed here. Actually, I just created inside of it, so that's the reason it's not able to identify the training data set. Now, simply I will give here this. So this is the training data set. Let me just simply see what's the issue, and I can tell you this is a really good tool which is able to identify why my training data set is giving the error. So I created this here. I have certain images for image classifications, right? Image classification. Just a second. Let me just add up a new folder. And so, see how you need to do is, let's say I am going to identify my chef gender, and I am going to put up I'm creating my two training. I need to create two different folders. One is like training data, and another is the testing data, where I need to ensure that I'm providing certain classifying information. So I just copied here and go to my folder, paste it here, and then I will be going to for the testing data. I just simply create same for testing data, which I will put up here in the testing information. And yep, now try to use in the CoreML this. Cool. Now I will give a testing data too. Now let's train this model and see how that behaves. Now I trained this model. Okay, now I will test it, and now quickly just see how that behaves when we are going to give certain input to it. Okay, so let me give the same example which I used earlier in our previous CreateML. I'm giving to test with the same image, and let's see it's able to identify. See, I give an image of a female chef, but it's saying that my model is saying the male chef, which is a 94% confidence, and female chef is a 6% confidence. This is what machine learning bias. Let's see this quick video which gives you more explanation about it.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone?
Yeah, so see, these are the different kind of machine learning bias which happens. Now, let me tell you what kind of machine learning bias I did. So if you look upon my training data, I provided a lot of images sets for male chef, whereas in the female chef section, I just provide 2 images. So due to this data inconsistency, my model is really not giving the correct results. And that's how a machine learning bias happens. So we really need to ensure that we are avoiding machine learning bias as much as we can. And how we can do that? So let's talk about it. We really need to ensure when we are training our model with the data that we are regularly doing our data monitoring. We really need to ensure that the data which is going through our machine learning model for training, we are doing it for a multiple pass annotations. We are doing a proper research and awareness for a certain business use case for which we want to train our model. We also need to ensure that we are keeping in mind about diversity. And if really required, we also need to take an expert advice for a certain specific business needs to identify the data collections. Keeping these all things in mind, we can really avoid machine learning bias. Now, I will going to give you a quick tip to integrate much CoreML in a Xcode project in a Swift language. The few simple 3 steps. Step 1, you just need to simply integrate with it with a CoreML model, generate a CoreML model using and provide the model name in it. And here you need to just ensure that you are adding up a VN Core, initializing a VN Core ML request object. And once the request created, you're going to handle the request handler in a async queue. Once the action perform, you will get a result in the process classification where you will be able to see the results data. Let me quickly show you. I make a simple app which simply take the input as a voice recognition and able to do a text classification to identify certain things. So here is my class. Here is my text recognition class where I'm using a BERT model which is an open source model provided by the Apple. And I'm using the BERT input and method like find answer where I will provide a certain data as a document and I can do a smart questions around it. This is a very good example where if you want to build an app for considering today's situation of COVID for the big stores or a big workshops where we have very less people working on those, and they want to know how that system works in a big workshop or a big storage shops or in the big stores. So let me quickly run and tell you how that works. I just make a simple app which I'm pulling up the data from our XT Summit site, and I can ask a simple question using a speech recognition, and it's able to answer me according to it. This app can work offline. You don't need to go and look into the site anywhere. Just simply ask the question and it will be able to answer. So let me ask one question quickly for you. How many speakers are there in an event? Oops. See, as I'm a developer, I put up some breakpoints. So quickly run it and see what comes up. How many speakers are there in XT Summit?
Your app with just a few lines of code.
Yep. So yeah. So this example I can provide you this offline, and this able to use a BERT model and pull out the information offline, like pull out the data from our XT Summit site where you can ask certain questions on it.
Total 72.
Yeah. See. So I know I put up certain breakpoints and all, so due to which gives our certain
Namit
delay
Nayak
results.
topic is on the machine learning.
This
Bring
can
on
be
device.
used further. This can be enhanced further and can be used in a different use cases. That's all from my side. Thanks.